Okay, this lecture is over Module 13 of the curriculum entitled ICMP. ICMP stands for Internet Control Message Protocol. So as always, we start with why should I take this module? And this one's pretty brief to basically learn about ICMP and related tools. In particular, what will you learn in this module? We'll learn about the various types of ICMP messages. We've possibly talked about a couple of them before. We'll learn about a few more. And then I think we have used both ping and trace route, which depend upon a couple of the ICMP messages we'll talk about. So we'll talk about those utilities in more detail as well. So ICMP was around in version 4 of IP version 4, and it's also around in IP version 6. The two protocols which we'll discuss further down are referred to as ICMP v4 and ICMP v6. Down at the bottom of section 13.1.1, it talks about some of the messages or things that you can do with ICMP. We can use it to determine whether or not a host is reachable. We can pass messages telling that a particular destination or a particular service that we're trying to get to is unreachable. And then we've talked about time to live in IP version 4 and hop count in IP version 6. If those counters get to 0, then it passes back a time exceeded message. So those are some of the things that ICMP will do. So we'll talk about the first one, which is host reachability. This is ping. Ping sends an ICMP echo request, basically saying, hey, I'm sending you this packet. I want you to echo it back or send it back to me. That sending of the message back is called a ICMP echo reply. So here we have two hosts, 10.1 over here on this network, 30.1 over here. And if we play this, host 1 is trying to determine if host 2 is reachable, so it does a ping. It sends this echo request. If the echo request makes it to host 2 and host 2 is functioning correctly, then it'll send back an ICMP echo reply, which is basically saying, yes, I got your message, I'm here, here's a reply back to you. As far as destination or service unreachable, this happens when a packet cannot be delivered to the destination. There are several subsets or codes that tell why it is unreachable. So in the case of destination unreachable in ICMP version 4, we have that the network was unreachable, a particular host was unreachable, protocol was unreachable, or the port we were trying to go to was unreachable. In ICMP version 6, we have no route to destination, administratively prohibited, such as a firewall, beyond the scope of the source address, address unreachable, or port unreachable. So somewhat similar messages, yet different. 13.1.4 is talking about time exceeded. Again, IP version 6 uses TTL, time to live, and IP version 6 uses a hop count. Every time it passes through a router, those values are decremented by 1. If they ever reach 0, then it will discard the packet and send a time exceeded ICMP message back to the sender. One thing they're doing is they're telling you that time exceeded is used by traceroute. Traceroute is kind of a based on a modified ping. It's using an ICMP request and reply, but what happens is it messes, instead of setting the time to live or the hop count to a high number and then having it count down, it sets it to 1. So it'll set the time to live, we'll talk about IP version 4, to 1, and it'll say send a packet to kctcs.edu. So that packet will go to the first router. That router will decrement the time to live to 0, and it will return that. Well, based on the header information in that packet that's returned, it can tell the name or IP address of the router. It can tell how long it took for a message to get to that router and get back. Then it sets the time to live to 2, and then again says send an ICMP echo request to kctcs.edu. It'll go to the router we already know about. The count time to live will be decremented from 2 to 1, so it will then go to the next router. That router will decrement it to 0 and send a packet back. So now we know about the second router. So it continues doing that, increasing the time to live by 1 until the packet actually makes it all the way to the destination and comes back. So basically, this tool is called trace route because we know the route it took, or the series of routers it went through between our source machine and whatever destination. For this example, I was using kctcs.edu. So I can't remember if I've assigned trace route yet or not for you to do in a homework. If I've not, that will probably appear in the next homework or two. ICMP version 6 has a couple of things, or makes use of a couple of things that we talked about in Module 12, in particular router solicitations and router advertisements. So down here it talks about those. So basically, a router advertisement, the one that is selected, says, hey, all IP version 6 devices, I'm router 1 or R1, and I can use SLAAC, which again is stateless auto address configuration, to create your globally unique ID. So that's what it does. It sends that message out. The next one is the router solicitation. So basically that's used to request the message that we just talked about. So the machine is trying to find out how it can set its IP address based upon the information it gets back from router 1 in the router advertisement message. We talked about this process in detail in Module 12. An NS message is basically one that is going to send back to check the uniqueness of an IP address, that is trying to eliminate duplicates. They talk about DAD protocol. I don't know that they actually defined what that is. I don't see it right there offhand, but it stands for duplicate address detection, and that's what it's using to check and make sure it got a unique ID. That protocol starts with a neighbor solicitation message to try to identify neighbors and their IP addresses. And then the NA is a neighbor advertisement. Basically what it's doing in the graphic, again, last time we saw that if we clicked on this little icon here, we can make the graphic bigger. So what happens is the neighbor solicitation message is sent from the router, and PC1 in this case is going to basically respond back and say, hey, I'm here. Here's my IP version 6 address, and here's my MAC address, so that it has information about its neighbors, in this case PC1. So 13.1.6 is a check your understanding on the basics of ICMP messages. you can do those on your own. Going back, talking a little bit more about ping. In the case of ping, as we saw in the animation a while back, it's going to send a packet all the way, hopefully, to the destination host, and hopefully the destination host is going to send us back an echo reply. Ping is a very basic, widely used debugging tool. What happens is if you can't reach a remote host, then maybe what you're going to do is you're going to ping the loopback address, which is 127.0.0.1 in IP version 4. In IP version 6, the loopback address or localhost, synonyms for each other is : 1. So we've discussed this, but it's been a while. If you ping the local host, the packet goes down through the TCP IP stack, gets to the point where it's about to leave the NIC card and go out on the network, and then is returned back up to the ping command. So that makes sure your host is configured correctly and that your NIC card is functioning and nothing else. After you get a response from the loopback address, if that is successful, or if there was a problem and you fixed the problem, the next thing you would do is ping the default gateway. So if you were at home, this would be your multifunction device or something like that. If you're your work, it'll be a router on the edge of your network. If you're able to successfully ping the default gateway, then that means your network connection's plugged in, the switch it's plugged into is fine, probably the switch is plugged into a router, that connection's fine. It's making it to the closest router and coming back to you. In between this step and the third step, a lot of times what you would do is if you knew the IP address of a device at your ISP, you would ping something at your ISP to make sure that it could go through your modem and make it to the ISP. And then after that, you would ping the remote host and see if it is able to get a packet to it or not. So I discussed those in quite a bit of detail. It looks like it's going to talk about it a little more here. Like I said, the big thing is 127.0.0.1 is the local host for IP version 4, which they're showing here. Next, you would ping your default gateway like I explained. Either you know what your default gateway is, or here they show you going into the IP version 4 TCP IP properties, finding out that the default gateway is 10.0.0.254, and then pinging it. Kind of glad they used 254 to stress that a lot of times we use .1, but it is not always that. Sometimes it's the highest usable IP address. And then finally, you would ping the remote host. There's an animation here. I believe it's going to ping a host on the local network, and then it's going to ping a host on another network. Okay, I recalled incorrectly, so I guess they're just doing what's shown up here, is that 10.0.0.1 was trying to ping a device over here in this network, and what we have up here is the routing table that just tells what network is on what interface of the router. Traceroute is entitled or subtitled Test the Path because we're going router by router trying to determine this. So they're going to show us this. So from 10.0.0.1, we send it out with a time to live of 1. It hits that router, decrements it to 0, sends a time exceeded message back. We then send out a ICPM request with a time to live of 2. This time it makes it to the second router before we get the time exceeded. Sends that back to the host doing the trace route. We send it out with time to live of 3. It goes through 1, 2, 3 routers. Gets returned, time exceeded, so we now know information about the third router. And then next it'll send it out with a time to live of 4. So it'll go 3, 2, 1, make it to the destination. That will be, and since it made it to the destination, it will just send back a normal ICMP echo reply. And we have tested the path and or traced the path from the source machine to the destination machine. 13.2.6 is a packet tracer talking about verifying IP version 4 and IP version 6 addressing. So I will be assigning that. So watch for that to appear in Blackboard. That's followed by 13.2.7, which is another packet tracer on using ping and trace route. So I will be assigning this one as well. If we move to the module practice and quiz, this was a pretty short module. It starts out with a packet tracer about using ICMP to test and correct connectivity. This is a pretty short packet tracer. I will be assigning that. So watch for that to appear in Blackboard. 12.3.2 is a lab, which is basically the same thing as the packet tracer above, intended for hands-on in-class equipment. So since this is exactly the same as the packet tracer, I will not be assigning this lab. And that brings us to the very end of the chapter. What did I learn in this module? You can read through this on your own. This one's a little shorter than most of them because it was a short chapter. And then finally we have the quiz over module 13. So you can do that on your own. I also think that module 13 is the last module in your next module group exam. So watch for information to appear in Blackboard about your module group exams. And that finishes up module 13.